All right, Mr. Niels Bohr is the next scientist that we're going to look at. And Bohr studied the relationship between electrons in an atom. He was very interested in electrons. One of the experiments that Bohr did, or other scientists with Bohr, they looked at what happens to atoms when you put them through the accelerometer. So in this one, just like with Rutherford's accelerometer, you shoot an atom in, it gets busted up into its parts. We see that from this we get particle A, which is attracted to the positive magnet, which means it's got a negative charge. We have positive B, which does nothing. Interesting, so that implies that it has no charge. And then we have particle C, which is attracted to the negative, which tells us that it's positive. So he was able to see through this experiment that there are 3 particles in an atom. And importantly, when we look down here, all 3 of them were going the same speed. And particle B and particle C hit with basically the same force. So when they impacted in the machine here, they hit with the same force. However, particle A hit way lighter, way less of a force. And so from that, he realized that the negatively charged particle A here, is very light and small, while particle B and C are massive and big, with B being neutrally or no charge and C being positively charged and attracted to the negative side of the magnet. There is a really cool simulation you can run if you would like on Canvas. You can pull up the slides to run this. It's very cool. You get to see basically what happens when you shoot certain light particles at an atom. Here's my atom. Certain colors of light particles will be bounced off. They can interact with the electrons in the atom, and certain colors just do nothing. That's really cool. So if you get a chance, you should check that out yourself. Okay, so going along with light. So Bohr realized that, hey, light interacts with electrons. So he wanted to study more about it. And so he looked here. He saw, okay, here's all the energies for these different colors of light. Red light has 1.75 electron volts of energy. And the wavelength of that light is 650 nanometers long. Basically what he realized is every color of light has a unique energy and a unique wavelength. And as part of that relationship, he also realized that the particle with the highest amount of energy, in this case the UV light here, has the smallest wavelength. And the one with the lowest energy, this infrared, has the biggest wavelength. So he realized that as the energy goes up, the wavelength goes down. And basically that there's a relationship between the color of light and its energy or wavelength, that not all light is the same. And for his last experiment, what Bohr did was something you've probably seen before, where he took light and refracted it through a prism. So when you take something like sunlight through a prism, it breaks up the white light from the sun into all of its parts. So you get all the full colors, the nice rainbow, all the different colors. However, he did the same thing with certain gaseous atoms. So he took hydrogen, put it in a tube, ran electricity through it, and it gave off light. And he did the same thing with that light as he did with sunlight, and was able to see that the hydrogen gas, rather than giving off a full rainbow, all the colors of light, gave off certain very specific light colors. So maybe just a little bit of blue, some red, greens, and so forth. And he did this with a couple different atoms and was able to realize that, hey, the electrons in hydrogen can only give off certain colors of light. Which he then related up here and said, hey, wait a second, if they can only release certain colors of light, then that means that the electrons only have certain energies that they can be at to give off light. Which brings us to his model. So Bohr's model of the atom, there's two kind of main things. One of the things is that from the works of the other scientists is they realize that the nucleus is no longer just a positive charge, that it's actually positively charged protons and neutrally or no charge neutrons. And that those are big, much bigger than electrons, and those are what's in the nucleus. Now, along with that, probably more importantly, is that Bohr realized that electrons exist in quantized energy levels. Quantized energy levels. That basically the electrons are orbiting like planets around the sun, around the nucleus. And that each orbit or each energy level here has a specific amount of energy associated with it. So part of what he said was that, hey, maybe the atoms or the electrons on this first orbit have 3 energy. Maybe all the electrons on the second orbit have 5 energy, and so on and so forth. And because the electrons can only exist at these certain energy levels, when you run electricity through them and the electrons begin to jump around and give off light, you're only able to see specific colors of light.